Okay, so for the third part of our exercise, we're going to be working off this topographic quad, which I gave you a photographed copy of, and I sent out this image for you to download. And I've also got Google Earth pulled up on this area, although we can do everything on here without using Google Earth in class. So the first question asks us to find Willow Cutoff in Albemarle Lake, which is an oxbow lake. There's about 100 oxbow lakes on here. In the center of the map, what natural features shown on the map suggest that a channel of the river once followed a course between the boundary course and the present course. So to understand what that means, we have to understand the boundary course. And so you can see the boundary between Louisiana, which is over here, and Mississippi, which is over here. And so the boundary between those two is this line that goes, I don't know why I'm pointing at the screen, you can't see that, that goes along right in here, and then comes back down and goes along here, all the way down. It's also the boundary between East Carroll Parish and Issaquah County. And so it goes along here, comes down, goes over this way, down this meander, comes back up, and goes down here by Vicksburg. Okay, so that's the current boundary today. At one point, that was the boundary of the river, but as we can see today, the river doesn't follow it in some places. It's following it here and here and here, but it doesn't follow it there. The boundary between the states goes up here, but the river just goes straight down, and then the same thing happens here. So the boundary course is shown on this line here. The present course is just the course that the stream is taking, right? So it says to find Willow Cutoff in Albemarle Lake, and what natural features shown on the map suggest that a channel of the river once followed a course between the boundary course and the present course. Okay, so here's Willow Cutoff right here. You have to zoom in and look at it, or you can look on your map. And here's Albemarle Lake up here. So at one point, when the boundaries for Louisiana and Mississippi were determined, they determined that it was just the center of the Mississippi River. That was going to be the boundaries between the two. And at that point, the Mississippi River flowed up this way. And so this big meander up here, that was the border between Mississippi and Louisiana. But clearly we can see that at some point the Mississippi River cut off that meander and has filled it back in, so we have this oxbow lake here. So what the question is asking is that what natural feature shown on the map suggests that the channel of the river once followed a course between the boundary course and the present course. Well, so that means that here's the boundary course, here's the present course, and it's asking is what natural feature suggests that at some point the river flowed between these two. Well, right here, you can see there's an oxbow lake between the boundary course and the present course. So that means that at some point, the river flowed along here, and it got cut off right here. So you had a shortened meander there, and at some point, this shortened meander got cut off right here where the river flows today. So, obviously the answer to that is there's an oxbow lake in between Albemarle Lake and the Willow Cutoff. Name 2 other oxbow lakes shown on the map. There are a million of them. There's Eagle Lake right there. There is, can't really see these to tell you the names of them. Let's see. It's like 5 Mile Lake right there. Is that Goose Lake right there? There's Providence Lake, Lake Providence right up here. So there are a whole bunch of oxbow lakes on here that you can look around and find. The second question says to compare the length in miles of the boundary course versus the river main channel of the present course. You can measure the distance with a piece of string, which is what I asked you to do. And to do that, all you're going to do is you're going to take the string I gave you, and you're going to use the string to follow the boundary course. You're going to lay it along here, put your finger on it, lay it along here, put your finger on it, lay it along here, put your finger on it, lay it along here, put your finger on it, and so on and so on and so on. All the way along here, all the way along here, all the way along here, and so on and so on and so on, until you get all the way down here. Now, I obviously don't have a string that I can put up on the screen to do this, but I can use Google Earth to measure this out, and we'll determine how far that is. Okay, so I used Google Earth to measure these paths out the way that you would have used a string to do so, and so the present course was about 65 miles, and the boundary course is about 115 miles. Obviously, there's a little bit of leeway there based on how you measure with a string, but roughly that's the difference. And so the amount of shortening is asking the question: how much shorter is the path today, the present course versus the boundary course? And so it's about 50 miles shorter. So if we want to look at number D, or letter D there, the present course length represents the percentage of the boundary course length. I mean, all we're doing there is just plugging the numbers into the calculation, and we can use our calculator to do that. And so the present course, which was 65 miles, divided by the boundary course, which was 115 miles, times 100, just to make it a percent, is 56.52%. So the present course is only 56% of the boundary course, so it's really, really shorter. So in general, how is the gradient of the present course different from the gradient of the boundary course? In other words, the present course steeper or less steep than the boundary course? Well, to figure that out, I mean, you could just sort of figure it out because it's covering the same distance in a lot shorter path. To really calculate the gradient, what we would do is we would look at the elevation at the top of the map, and then look at the elevation at the bottom of the map, and look at and divide the length of each path into that distance. So I can calculate that really quick. We don't have to actually calculate it. We can just figure it out, but let me calculate it really quick, and we can analyze that. So you didn't have to do this calculation, but I went ahead and did it anyway. The elevation of the stream up here was about 100 feet above sea level, and then down here at Vicksburg, it's about 75 feet above sea level. So in all of these miles, the elevation of the stream only goes down about 25 feet. It's really, really flat here. So to figure out the gradient, we want to know how many feet per mile does the stream go down. So you just divide the number of feet in the elevation change. You take the length of each course and divide it into that. So the gradient of the present course, which you weren't asked to do, I didn't ask you to do this, but the gradient of the present course today is that the stream is changing in elevation 0.384 feet every mile. So that means that every mile the Mississippi River is going down in elevation about so what would that be? About 4 inches. The length of the boundary course, the gradient of the boundary course only changed 0.217 feet per mile. So that meant that for every mile that stream traveled, the length of, for every mile, the elevation only changed 0.217 feet, so that is, how many inches is that? 0.217 feet, so that's 2.5 inches per mile. Either way, neither one of them is very steep, but the question asks you which one is more steep, and that, of course, is the present course. You didn't have to do the calculation to figure that out. You could just say, well, the stream is traveling less distance, and the elevation obviously didn't change between those two, so the present course is obviously going to be a little bit steeper, even though it's still not very steep. The last question says, compared to the boundary course, why would the present course of the Mississippi be an advantage to river traffic, such as barges? There's a lot of different answers to this. Some people have answered, well, since the course is shorter, it's going to save on fuel and things like that, which I guess makes sense. And it's going to save on time of travel. However, probably the realist answer is that as the course travels now, there are fewer meanders for the barges to navigate, and as such, it's going to be safer for them to navigate. And also, since there are fewer fewer meanders for them to navigate, there are going to be fewer point bars and fewer areas where there's deposition of sand. And sometimes for barges traveling on a river, they can't travel in certain parts of the river because of sand deposition, and it's the river isn't deep enough for them to travel. So that's probably the most realistic logistic concern. Anyway, I just wanted to go through all that stuff, and hopefully that helps you understand what we went through with this exercise today. All right, have a nice day, and we'll see you in class.